Good morning, classmates. Good morning, Sir Ran. This is Ryan Rolada from Penang, Malaysia. I'm going to be reporting on concurrency within the framework of an operating system. Concurrency is the execution of several instruction sequences at the same time. It is the tendency for things to happen at the same time in a system. Concurrency in an operating system happens when there are several process threads running in parallel. These threads may communicate with each other through either shared memory or message passing. An OS is a concurrent system. Concurrency arises naturally in an operating system when it supports concurrent applications and because it must also interact directly with hardware. So goals of concurrency is to ensure that if one task blocks, another task can run. Another important goal is to allow each task to progress when it is not blocked. Benefits of concurrency: being able to run multiple applications at the same time. Better resource utilization allows a better average response time of individual applications. And of course, better performance of the CPU. So in here, this is an image that will show us a simple diagram about concurrency. So we have two threads, P0 and P1. P0 executes, then gets interrupted by an ISR. It goes to idle state, but before that, it saves its state to a process control block 0. So process 1, P0 and PC1 kicks off, but prior to starting, it reloads its state from PCB1. After a while, it gets interrupted again by some ISR, saves its state to PCB1, process 0 kicks off after reloading its state from PCB0. So common problems that occur when we take out concurrency in an operating system. Number one would be a race condition. This happens when there are more than one process thread attempts to access the same state of information, which could make the state internally inconsistent. So an experience with this is during programming, when you are doing multi-threaded programming. If you won't be using semaphores or locks, then there's a tendency that when accessing a common resource, you will experience a race condition. Another problem would be deadlock. So deadlock happens when two threads of control are blocked by waiting for the other to take some action. So in this image here, I'm showing to you a sample of a deadlock. So we have two threads, T0 and T1. T0 is locking on resource 1. T1 is in turn waiting for resource 1 to be released so that it can use it. So T0 is also waiting for resource 2 to be released, but unfortunately it is locked by T1. So this is an example of deadlock. So that's all for my presentation. This is Ryan. These are my sources. Thank you for watching. This is a requirement for IS 215 Advanced Computer System. Thank you.